So today's lesson is on classifying and then adding and subtracting polynomials. So some vocabulary. A polynomial is an expression which is the sum of terms, and it's written from largest to smallest degree. And poly means many, as you can see down here. So we classify all polynomials as any amount of terms that are being added together or subtracted from each other. But then we can classify even more specifically. So if it's a monomial, meaning it has one term, a binomial, meaning it has two terms, and a trinomial, meaning it has three terms. And then anything that's four or more is classified as a polynomial. So let's take a more specific look at how we classify. So polynomial is based on its degree and the number of monomials it contains. And so when we have a polynomial, it could be just a term of a constant, a 6. So since there is no variable in that, our degree is 0. Because if we have 6 times x to the 0, we know that x to the 0 is 1, so 6 times 1 is 6, so that would be our lowest term answer. But for classification of polynomials, we are looking for the largest exponent value with the variable. And in this case, since there is no x, our degree is 0. So then we have negative 4x. That is one term because it is not separated by addition or subtraction. It is separated by multiplication. And when we don't see the exponent, it's really a 1, so that's the first degree. And then we have 7x plus 4, and that's also a first degree. Now this one, 3x squared plus 4x minus 6, since 2 is the largest exponent, it is the second degree. This one has a 3 as its largest exponent, so it's a third degree. And then this one has a 4 as its largest exponent, so it is the fourth degree. Looking at these same expressions in relationship to terms, so since there is one term, it's a monomial. One term, monomial. Two terms is a binomial. Two monomials being added together is a binomial. Then this one has 3 monomials, so that makes it a trinomial. And then we have 2 terms, so it's a binomial. And then we have 4 terms, so we call that a polynomial. So one of those 4 classification for terms, and then degree is just the largest exponent value in the expression. So degree is classified by the largest exponent in the expression. Now when adding, we're going to classify first. So we're going to write each polynomial in standard form, then name each polynomial based on degree and term. So 5 minus 2x is in lowest terms, but it's not in standard form in regards to exponent order. So since the x has an exponent of 1, it is the highest degree. So it's a first degree, and it is a binomial because there are 2 terms. But in standard form, we write it as negative 2x plus 5. And on b, we have 2 terms that are to x to the 4th, so they are like terms. So we can add 3x to the 4th plus 5x to the 4th to get 8x. And then these other 2 terms are not like terms to anything but themselves, so they just get rewritten in order of highest exponent to lowest exponent. And so that's why we have 8x to the 4th plus 2x minus 4. So again, the 4th degree, and it is a trinomial because it has 3 separate terms. In example C, we have 2 like terms of 3x to the 5th. So 3x to the 5th minus 2x to the 5th is 1x to the 5th. And then we have a 7x and a negative 2, so that becomes plus 7x minus 2. So its highest degree is a 5th degree, and it is a trinomial because in standard form, some of those, it started off as a polynomial, but it, excuse me, it reduces to a trinomial. So we classify it as its lowest polynomial because there's only 3 terms in the standard form. All right, so now we are ready for adding the polynomials. And so you can see we have a trinomial plus a trinomial. And in addition, we really just drop the parentheses and combine like terms. So our 6x to the squared is from 4 plus 2. And then next, our lowest next exponent would be the x for the 1, and so 6x minus 9x is negative 3x, and 7 plus 1 is 8. If we were to classify this, this would be the second degree trinomial. And on B, we have a trinomial plus a trinomial, so again, combine like terms, so 4x squared minus 2x plus 0, because 1 minus 1 is 0, but in standard form we don't write the plus 0 just like always, so our lowest termed standard form would be 4x squared minus 2x, so that would be a second degree binomial. And on C, we have a polynomial plus a polynomial. We have 5 terms plus 5 terms. So again, we look for like terms, and we start with our largest exponent value. So 2x to the 6th is our largest exponent, and there are no other x to the 6 terms, so we just write it once. And then next we have x to the 5th, and we do have 2 of those terms, so negative 1 plus 7 is 6. And then after x to the 5th, we go to x to the 4th, and there's only 1 of those terms, so it stays as is. Then x to the 3rd, we have 2 of those, so we combine those by 3 plus 9. And then the x squared, we have negative 14 plus 13, so we have negative 1x squared, or negative x squared. And then lastly, we have our constants, 13 plus 2 is 15. So notice I have it the highest exponent first, and then going down in order from largest to smallest, and that would be my answer. It's a polynomial to the 6th degree. So to summarize, combining or adding polynomials, we combine like terms and make sure the largest exponent to smallest is listed in order for the final answer in standard form. So pause the video if you need to get caught up, and rewind it and go back if you need to. But next, let's take a look at the subtraction. So when subtracting polynomials, it's similar to addition, except for we have a negative in front of a group. So that means that's really negative 1, and we have to then distribute that negative 1 to each of the terms, because in other words, we are subtracting each of these terms from its like term from the first polynomial. So we have 2x squared minus x to the 3rd, and then we have 5x squared plus 8x squared, and then negative 3x does not have any other like term, so it stays. And then 11, that times the negative 1 makes it negative 11, and it is the only term, so it stays as well. So this trinomial minus the trinomial ends up being a polynomial to the 3rd degree. In the example on B, the same way, we have to make sure we take that subtraction and multiply each by a negative, so that makes each of those their opposite, and then we combine like terms. So 2x to the 3rd minus 1x to the 3rd is 1x to the 3rd. Negative 3x minus 4x, negative 7x, and 6 plus 12 is 18. So we have a trinomial to the 3rd degree. Now, on example C, we've got a polynomial minus a polynomial. So again, we distribute the negative 1 to each of the terms to create their opposites. Then we combine like terms. So negative 1x to the 3rd plus x to the 3rd is 0x to the 3rd. Negative 5x squared minus 3x squared is negative 8x squared. And then x minus 10x is negative 9x. And negative 1 plus 9 is positive 8. So since we have a 0x to the 3rd, we do not leave that 0 term in our standard form, so we reduce it one more step. And we just have it as negative x squared minus 9x plus 8. So it's a trinomial to the 2nd degree. So to summarize our subtraction, we distribute the negative 1 first to the second polynomial, then combine like terms and keep them in exponent order just like addition. Again, pause your video and get caught up and go back and work them out to make sure you're understanding what you are doing. Before we finish, I want to go over a few more things or a couple of items and show you about those zeros again. So if I start off with 5x to the 4th minus x squared plus 5, that is in lowest term because we don't have any like terms that can be combined. Because remember, in order to combine them, they have to have the same exponent value. Otherwise, they are considered unlike terms and they cannot be grouped together. But in between here, we actually have a value for every exponent. So 5x to the fourth, then it would be 3. So that's actually 0x to the third minus x squared, and then plus 0x, because we don't have an x term, and then plus 5. So these terms have a coefficient of 0, so we don't write them in lowest terms whenever we are simplifying them. But I just wanted to make you aware that when it does have a 0, it can have a coefficient of 0, but then we simplify that out so that it doesn't leave it there.